Hello and welcome. This is another recording for Edexcel's higher tier paper 3 paper sat in November 2022. So paper 1 and 2 have been and gone. This is the last one of them all. So I'm going to talk you through all the questions step by step. So let's just get straight to it. Question 1, we have to make A the subject of the following formula. P equals 3A minus 9. So to do that, all it means is we need to have A written first on its own. So our target is A equals something. So right now, we need to rearrange this to have A on its own. One of the first decisions we could make would be to get rid of this minus 9 by adding 9 to both sides. So that would give us, instead, P plus 9 equals 3A. Then to get from 3A down to just 1A, we could then simply just divide both sides by 3. And so that would give us that P plus 9 all divided by 3, in other words, all over 3, equals just 1A. But if A is a subject, A needs to be written first. So therefore, we need to write it as A equals P plus 9 all divided by 3. And then we've got it in terms of A equals, therefore that's our answer. And we've got the first marks on the paper in the bag. So let's move on now to question 2. Question 2, Rob has been asked to divide 120 in the ratio 3 to 5. Here's his working. So he's done 120 divided by 3 is 40, and 120 divided by 5, which is 24. Rob's working is not correct. Describe what Rob has done wrong. So there's a couple of ways of doing this, but the main thing is, to divide 120 in the ratio 3 to 5, you need to do 3 plus 5 and realise there's 8 parts in total. So each part will be 120 divided by 8. So I'd just say something quite simple, really. I'd say something, the fact that he's simply not divided by 8. He should have divided 120 by 8. Keep it simple, something like that, to get you the mark. Question 3 could be where you get slightly confused. I'm going to explain what we need to do here. 200 students chose one language to study. The key thing it says here is each student chose one language from French or Spanish or German. So there's not going to be any overlaps here. If they're just choosing one language each, it's not going to be a Venn diagram question. It's common here that you're going to think French, Spanish and German, do 3 circles and see where they overlap, like in a Venn diagram. But here, these are going to be mutually exclusive. So actually this one is going to be done best using a two-way table and not a Venn diagram. So the setup I'd suggest would be something as follows. So a table, spaces for French, Spanish, German, boys and girls, and 2 side columns, well, 1 column and 1 row for grand totals. So the grand total number of students is 200, so we can add this in over here first of all. And we're told that 90 are boys and the rest of the students are girls. So if 90 are boys and the rest are girls, that's essentially saying that 110 of them are girls. So we've added that piece of information in. 70 in total chose Spanish, so Spanish total is 70, so that can be ticked off. 60 of the 104 students who choose French are boys. So 104 people chose French, I'm going to say France. 60 of those are boys. So the number of girls that took French will be 104 minus 60, which is 44. So again, we can tick that one off. It then says 18 girls chose German. So German girls, 18. Now our target is just simply to find out how many boys chose Spanish. So we need to work out this number here. So let's just fill in the missing bits of information. So for example, if we know the total number of girls is 110, 44 chose French and 18 chose German, then we can work out the number of girls that chose Spanish by doing 110 minus 44 minus 18. So if we do that here, 110 minus 44 minus 18, that gives us 48. And therefore, we can then do 70 minus 48 to find out the number of boys who chose Spanish. So finally, 70 minus 48, if you want to use a calculator, you can do. That'll give you a value of 22. So therefore, the number of boys that chose Spanish must have been 22. Question 4. Karina has 4 tanks on her tractor. Each tank is a cylinder with diameter 80 centimetres and height 160. 4 tanks are to be filled completely with a mixture of fertiliser and water, and the fertiliser has to be mixed with water in the ratio 1 to 100 by volume. She has 32 litres of fertiliser. 1 litre is 1000 cm cubed. Has she enough fertiliser for 4 tanks? You must show how you get your answer. The key word here I would suggest would be volume, and each tank is cylindrical, so we need to work out the volume of a cylinder. We're told the diameter is 80, and so from that, if we half it, you should realise that the radius is 40 centimetres. So I'm just going to add this on to the diagram over here, and then we need to remember how to calculate the volume of a cylinder. So luckily, and as you should know, there's a formula for that. The formula for the volume of a cylinder is pi r squared h, where pi r squared just means the area of the circular end, and h is the height. So the area of the circular end is going to be pi times radius squared. So v pi times radius, which is 40, squared, and multiply that by the height, and let's see what that gives us. So on the calculator, so shift pi multiplied by 40 squared multiplied by 160 gives us 256,000 pi. I'm just going to leave it like that for now. 256,000 pies. But she's got 4 of these tanks, so therefore the volume of all 4 tanks, that's just going to be 256,000 pi multiplied by 4. So if we just take our value on the calculator and multiply that by 4, we get 3216990. 3216990, and then it was, I think, 0.887. Now the units we've used here, we've plugged in cm, centimetres, so what the units will come out will be centimetres cubed. However, we are told that 1 litre equals 1000 cm cubed. So to convert from cm cubed to litres, we're going from a big number to a small number, and it's in a ratio 1 to n. Therefore, we need to divide that by 1000 to convert into litres. So if we just divide this figure by 1000, like we just said, that will spit out the answer in litres, which is what we want because she's talking about litres of fertiliser. So the best unit to use would be litres. So keep it stored on the calculator, divide by 1000, 1024 pi, press SROD, 3216.99 litres. So I'm going to call that 3217 litres to the nearest litre. So that's the volume of the 4 tanks which she is wanting to fill up, 3,217 litres. However, the fertiliser she's using needs to be mixed with water in this particular ratio. So the fertiliser to water is in the ratio 1 to 100. So we can work out how much fertiliser she can make how much mixture she can make from this fertiliser by using this ratio. So here's a ratio table. 1 lot of fertiliser is mixed with 100 lots of water to give 101 lots of the mixture. But she's actually got 32 litres of fertiliser. So if 1 lot of fertiliser needs to be 32 litres, then to go from 1 up to 32, clearly we need to multiply all values in this table by 32 to scale it up accordingly. So if we do that, 100 times 32, that would be 3,200 litres of water, to give a total mixture of 3,232 litres. So in other words, her 32 litres of fertiliser can make enough for 3,232 litres of fertiliser mixture. So that's how much she can make. To fill the 4 tanks, she needs to make at least 3,217. So what she can make for 3,232 is more than what she needs. So therefore, yes, she's going to have plenty to fill these 4 tanks. So to conclude by saying therefore, yes, she will have enough. So the key word is yes, or to agree that she has enough mixture to make. Question 5, we're talking about similarity, similar triangles. So ABC and DEF are similar shapes. We're asked first of all to work out the length of E to F. So EF here is this bottom side, and the side which relates to EF on the smaller one is BC. So I'm going to highlight BC and EF in red. Now, obviously this is a smaller one and this is a bigger one. I need to know what the scale factor is to go from the small to the big. So what we could do with knowing really is a pair of corresponding sides which we know the length of both. And luckily we have that. This right hand side we know the length on the small, and the right hand side we know the length of the big one. So if I highlight these in green, if we go from 5 up to 20, the scale factor we can work out by doing 20 divided by 5, or just by inspection, you can see that 20 is 4 times bigger. So to go from the small to the big, I need to multiply the lengths by 4. So I do the same with BC. So to convert from BC to EF, EF must be BC multiplied by 4. In other words, 4 multiplied by 4. Therefore, the length of EF is 16 centimetres. To work out the length of AB, which I'm going to put in blue, along with its corresponding larger side, this time I'm going from the big triangle to the small triangle. Therefore, rather than multiplying by 4, I'm going to be dividing by 4. So 22 divided by 4 will tell me the length of AB, and 22 divided by 4 is 5.5 centimetres. Question 6. The Keddy family is going to do a sports quiz and a music quiz. The probability that the family will win the sports quiz is 0.3. The probability that they'll win the music quiz is 0.35. Complete the probability tree diagram. Each set of prongs with like a common fork always needs to add up to 1. So here, there's 2 prongs coming off this fork. One's 0.3. They both need to add up to 1. So this one's 1 minus 0.3. That needs to be the other 0.7. In a similar way, this one here will be 1 minus 0.35, which is 0.65. And same for this one, which is the identical probabilities to this top fork. So 0.65 again. Part B, we need to work out the probability that the Keddy family will win both the sports quiz and, keyword there, and the music quiz. And with probability will usually mean one probability multiplied by the other. So I'm going to stick in a times sign there. So the probability in the sports quiz is 0.3. And then, apparently, they need to go on and win the music quiz. So the chance of then winning the music quiz after is going to be 0.35. So the calculation we need is 0.3 or 0.3 multiplied by 0.35. Let's see what that gives us. 0.3 multiplied by 0.35 gives us a probability of 0.105, or if you want to, can leave it as that fraction. Either's fine. I'm going to give it as 0.105. It's your choice whether you want a decimal or fraction. Doesn't really matter. Question 7. Change 8,000 cm cubed to cubic meters. Now there are formulae you can remember for these, but I'd rather just try and imagine any shape you'd like. A simple shape that's just a cuboid that has a volume of 8,000 cm cubed. I'm making up some measurements for it so it would have that particular volume. So you could do a 1 by 1 face, 8,000 cm cubed long. One I've gone for is this one. I've imagined one which is 10 centimeters by 10 by 80. This shape here does have a volume of 8,000 cm cubed. To change to meters cubed, I'm going to convert all these units step by step into meters, using the fact that 1 meter is 100 centimeters. So I can convert from centimeters to meters, going from the big number to the small, by dividing all of these measurements by 100. So 10 divided by 100, if I try that in a calculator, it'll give me 0.1. So in terms of meters, 10 centimeters, I can write that as 0.1 meters. In exactly the same way, the 10 centimeters at the bottom, I can again change to 0.1 meters. because that's what it is equivalently in meters. And 80 centimeters, if I were to convert that into meters as well, 80 divided by 100 would give me 0.8. So now in terms of cubic meters, the volume of this would be 0.1 multiplied by 0.1 multiplied by 0.8. So let's try that. 0.1 times 0.1 times 0.8. That gives a total of 8 times 10 to the minus 3, which just means 3 zeros and then an 8 with the decimal in the right place. So 1, 2, 3, 8, and the decimal goes there. Part B, we need to change a speed of 180 kilometers per hour to meters per second. So we need to change from hours into seconds, and as well we need to convert the kilometers eventually into meters. So let's just do this step by step. So 180 kilometers per hour, let's just change one unit at a time. First of all, I'm going to change the kilometers into meters. 1 kilometer is 1,000 meters. So to change from kilometers into meters, I'm going from a smaller looking number to a bigger one, and therefore we're going to multiply by 1,000. So if I multiply that value by 1,000, I've changed that part into meters. So 180 kilometers per hour is the same as 180,000 meters per hour. Next though, we can think about how many seconds an hour is. So an hour is, well, there's 60 seconds in each minute and 60 of those minutes in each hour. So an hour is 60 times 60, which is 3,600 seconds. So I can change that to 180,000 meters, and per hour is the same as saying per 3,600 seconds. So I've converted from hours into seconds, and over here I converted from kilometers into meters. But I don't want it per 3,600 seconds, I want it per 1 second. So to go from per second, per 3,600 seconds to just 1 second, I'll need to shrink this down. I need to divide that by 3,600. But if I divide the time by 3,600, I also need to do the same to that distance as well. So 3,600 and divide this one by 3,600 too. That will give me 180,000 divided by 1,600, which is 50. So 50 meters per second. On question 8, we're having to talk about a mean. So we're talking about 30 women and 20 men that attend a gym. The mean heights of all 50 people going to this gym is 167.6, and the mean height of just the 20 men that are going is 182 centimeters. We need to work out the mean height of the 30 women. So it's definitely a question involving the mean. So we need to remember a formula for the mean. So generally, to work out the mean, it's a grand total of all things divided by the number of people. So in this case, the mean height would be the total of all heights in question divided by the number of people we're measuring the heights of. So I'm going to introduce a formula triangle like this. Mean height is total of heights divided by number of people. However, we're not just talking about the height of just men or the height of women. We're talking about means for 3 different groups: men, women, and combined. So there's lots of different information going off at once, so it might be easier to digest this if we do it in an ordered, logical way, for example, in a table. I strongly suggest a table something like as follows. Then we can infill the information carefully without getting our wires crossed and confusing ourselves. So here, first of all, what we could add in is the mean height of all 50 people is 176.7. So the overall mean for all of them is 167.6. It then says the mean height of just the 20 men is 182. So just for the men, the mean is 182. And of course, we know the total amount of people as well. So we know there's 20 men, We're told there's 50 people in total. Therefore, the number of women must be 50 minus 20, which is 30. If there's 20 men, it must be 30 women. So 20 plus 30 gives us the 50 as needed. So what else we can work out now is also the mean for the men. So the mean for the men is 182. Sorry, I've worked that one out. So what we can do here next, we could work out the total height of all of these men, for example. So to work out the total height, we can use this formula triangle. So the total heights for the men, cover that up, is the mean height of the men multiplied by the number of men. So for the men, the total of heights is 20 multiplied by 182. So if we just do this on our calculator, we should get the following. So 20 multiplied by 182, that gives 3,640. So the total for the men's heights is 3,640. And we can work out the total height overall. 50 people with a mean of 167.6. We can multiply these two together to get the total heights of every single person. So now if we do 50 multiplied by 167.6, the total of all heights is 8380. We can now work out the missing total of heights for the women. So we can calculate this by doing 8380 subtract 3640. So take away 3640. We therefore can work out that the total heights of all these women is 4,740. Now we can work out the mean heights for the women. So the mean for the women is going to be the total of their heights, which is 4,740, divided by 30. So therefore the mean for the women, just calculate that quickly, divide by 30, we get 158. So therefore our answer we need is 158 centimetres, of course. You could do it without using a table. I'm not saying you have to, the question doesn't say you need to, but I think it could be very hard indeed without doing it in a table like this. Question 9 is standard form. So we need to write 6.75 multiplied by 10 to the minus 4 as an ordinary number. I'm going to show you how to do it without using a calculator because ideally you should know. If we have a number in standard form raised to a power of 10 which is negative, the quick trick here is if it's a negative power of 10 in standard form, written as an ordinary number, this number after the minus in the power is simply the number of zeros before the first non-zero digit. So it's a minus 4, so we can just write 1, 2, 3, 4, then 6, 7, 5. Then just put the first decimal point in between the first and second zero. So that's the easiest way of doing it. You can actually do it quicker without a calculator. Of course, so in an exam you may have forgotten or be panicking, so knowing how to do it on a calculator is obviously useful. So I'm going to show you this now. So on a calculator, if you were to type in 6.75 multiplied by 10 to the power minus 4, you should be able to get this as an ordinary number. However, if you press equals and then press SROD, your calculator might just refuse, it seems, to give you it as an ordinary number. There is an easy trick if your calculator is doing this. If your calculator is giving you 0.000675, nothing needs to change. If your calculator is doing this annoyingly, if it's a Casio ClassWiz, if you press Shift menu, number format, press number 3. We want it as a normal number, norm for ordinary, so press 3. And then option 2 actually works better for ordinary numbers. Option 1 will get it into standard form. Option 2 will make it always as a decimal if it can. So press option 2, then press equals again, and SROD, and then your calculator transforms nicely to giving you the answer as you need it. For part B, we need to work this out and give your answer in standard form. So again, type it in exactly as it looks in the question. So you've got a fraction line here, so press the fraction button. 2.56 multiplied by 10 to the power 6 multiplied by 4.10 multiplied by 10 to the power minus 3. All of that divided by 1.6 multiplied by 10 to the power minus 2. Press equals, and we get 659200. Again, I'll show you how to do this without using a calculator, and then how to check using the calculator. A number in standard form needs to be in between 1 and 10, the first part of it. Obviously, this number is a tiny bit bigger than 10. Where would the decimal need to go for that number to be in between 1 and 10 as required? Clearly, the decimal would have to go in between the 6 and the 5 to make it 6.592. So then we count how many digits are in between where the decimal needs to be in this number. It needed to be there. But in the number 659,200, the actual decimal is actually at the end there. So how many digits in between where the decimal needs to be and where the decimal actually is? We've got 1, 2, 3, 4, 5. Therefore, it's going to be 6.592 multiplied by 10 to the power 5. It's a calculator paper though, so you'd be maybe a bit foolhardy not to just double check that. So how to check on your calculator? If your calculator is not giving you a standard form answer, Shift menu, go to number format option 3 on this one, press 2 for scientific. Scientific gets into standard form because in science standard form is very often used. So press 2, and then here is just the number of significant figures you want it to be rounded to. If in doubt, just press number 9, then knock off any trailing zeros. So if I press 9, then press equals again, 6.592, forget all the trailing zeros, multiplied by 10 to the power 5. So that's how you can do it on a calculator and check it fairly nicely. Question 10. Peter asks us to subtract x squared minus 2x minus 4 from x squared plus 3x plus 5. So he's working us down here. So he's putting them in brackets, seems reasonable, but apparently he's made a mistake. So what is wrong with Peter's working? So x squared minus x squared, that seems absolutely fine. But here, we're minusing minus 2x. It might be easier to consider if I write in here, instead of a minus, imagine it as a minus 1. And if I were to expand this out, minus 1 multiplied by x squared, minus x squared, that's fine. But if I were to do minus 1 multiplied by minus 2x, and minus 1 multiplied by minus 4, that become positive 2x and positive 4. So these two minuses here should actually be positives. So explaining what's wrong with his working, I'd probably say something like this. Obviously that's wrong, that could be crossed out. It should be 5x plus 9. The x squareds cancel, 3x plus 2x is 5x, and the 5 plus 4 gives 9. So I try to say something like, he should have added the x squared and the 4 from the second bracket instead of taking away like he has done. Or, if you're not sure how to word it, the best thing you can do if you're unsure is just write down what it should be. So if in doubt, if you're not sure what to write down and you're finding it an awkward question, just say he should have got 5x plus 9 as his final answer, and he didn't. Question 11, x and y are integers. That just means they're whole numbers, which could be negative. Not in this case though, because x is bigger than 3 and y is bigger than 4. So x and y are whole numbers. X is in between 3 and 8, and y is in between 4 and 10. We're told that x plus y has to be equal to 14, and therefore to work out all the possible values of x. So just let's brainstorm this. If x is a whole number in between 3 and 8, then x could be 4, 5, 6, or 7. Similarly for y, if it's more than 4, it could be 5, 6, 7, 8, 9, but not 10, because it has to be less than that. So the initial possibilities for x and y are as follows. So these are the x's, and the others are the y's. So x, consider 4, 5, 6, and 7, and for y, let's just consider the initial possibility of 5, 6, 7, 8, or 9. So if these two need to add up to a total of 14, we can consider now what pairs we could have. So what we could have, the 7 here for the x, could pair with that 7, so x could be 7, that's allowed. 6 plus 8 would have worked, and also 5 add 9 would have given 14 as well. That 4 though, I can't add 4 to any of these numbers in green and generate the required answer of 14. So therefore, actually x can't be 4 in the end because that's just too small for it to work. So I just cross off that, hence only leaving 5, 6 and 7 as the actual possibilities for x that work. So therefore, x is either 5, 6 or 7. So we have to eliminate 4 and just be left with 5, 6 or 7. Question 12. Martin used his calculator to work out the value of a number p. He wrote down the first 2 digits of the answer on his calculator. He wrote down 1.2, complete the error interval for p. So the lower bound, it's obviously going to be at least 1.2. If he's wrote 1.2, common sense tells us it needs to be at least 1.2. Any other digits he adds to it will only increase it from 1.2. So the upper bound is actually going to be the absolute limit, not what p can be, because this inequality symbol here says p has to be strictly less than this upper limit. So he could have wrote 1.29, he could have wrote 1.2999. In fact, your calculator can actually help you to cheat here if you like. I'm going to show you how. So if I just show you how to do this. So he wrote 1.2, you could have put 1.2999 and so on and so on and so on, as many times as you want. If you press equals, your calculator will just say it's near as damn it 1.3. Technically it's a midgeon less, it's like a billion trillionth less, but it can be all the way up to, but not including 1.3. So truncated to 1.2 means the upper limit is 1.3. So between 1.2 and 1.3 is our answer for question 12. Question 13, Chen has this information about the time it took an operator at a call centre to answer each of 90 calls. A cumulative frequency graph's been drawn from this table, and we need to find 2 different things that are wrong with this graph. This question struck me. Normally, if it's asking to spot 2 things that are wrong with a question, you can normally pick more than 2. There might be 3 or 4 things wrong, but actually, there's only 2 things wrong with this, so you need to spot both and not include anything else. So the first thing you should hopefully notice is the vertical axis is labelled properly as cumulative frequency. The horizontal axis, though, is time, and that's not been labelled. So the first thing wrong with this is that the horizontal axis has no label. The second thing that's wrong is you need to remember cumulative frequency is always plotted from the endpoints. So it should have been plotted from 10, 20, 30, 40 and 50. So that cross there should have been here, and so on and so on. So actually what's happened is, without doing it intentionally because it's a mistake, Chen has actually just squished in this too much. It should be this way, and the reason for that mistake is Chen has plotted from the midpoints. He's plotted 5, 10, 15, whereas you need to plot from the endpoints instead. So that's the second mistake we need to say. So then we just say he's plotted from the interval midpoints when he should have plotted from the endpoints instead. Question 14, we have to simplify fully 3x to the 5, y to the 6, all to the power 4. A common mistake is to not raise all of these things on the inside of the brackets to the power 4. So I'm just going to illustrate what this actually means. So we're doing the bracket, everything in this bracket is going to be multiplied by itself 4 times. So we're multiplying 3x to the 5, y to the 6 by itself 4 times in a row, which actually would look like this if we did it the long way. 1 lot of itself, 2 lots of itself, 3 lots of itself, the 4th lot of itself. This just illustrates, hopefully a bit clearer, that we need to multiply everything here by itself 4 times. So 3 times 3 times 3 times 3, 3 cubed is 81. To work out a power of a power, you could add up all these x's if you really wanted to, but what you should hopefully remember is we multiply the 2 powers together if we've got a power next to a power on the outside. So 5 times 4, the final power of x will be x to the 20, and in a similar way for the y's, y to the 6 to the power 4, 6 times 4 is 24, which gives y to the power 24. So therefore, put as simply as possible, we have 81 x to the 20, y to the power 24. This one here, expand and simplify x plus 2, x minus 3, x plus 4. So multiplying out 3 brackets in a row. We can only really multiply out 2 brackets at one single time. So what I would tend to suggest to my students would be to multiply the n2 out first, get that result, and then once you've got that result, to multiply all of that by the first bracket x plus 2. So start at the end and work backwards essentially. So expand x minus 3, x plus 4. My favourite method is the grid method, like so. So write one bracket along the top, the other bracket down the side, and then just expand out. So x multiplied by x, x squared. X multiplied by minus 3, minus 3x. X multiplied by 4 is 4x. Finally, 4 multiplied by 3 would be 12, but 4 times minus 3 would give minus 12. So this simplified would give x squared. 4x, take away 3 of them, would leave just 1x, and then have the minus 12 as well. I now take that and multiply that by the x plus 2. So this becomes next x plus 2 multiplied by x squared plus x minus 12. We can make another grid for this and do the same method again. So doing a grid here, this time have 3 columns for these 3 terms and 2 rows for these 2 terms, something like this, and then expand out in exactly the same way. So x multiplied by x squared, x cubed, x multiplied by the single x is an x squared, x multiplied by minus 12, minus 12x, x squared times 2, 2x squared, x multiplied by 2 is just 2x. Finally, 2 multiplied by minus 12 is minus 24. So simplifying all the terms, we have an x cubed there. Then how many x squareds do we have? So I have 2x squared here, plus an extra x squared. That will give me in total 3x squareds. So plus 3x squared. Then the normal x terms, I've got 2 x's here. If I take away 12 x's from 2, 2 take away 12 is minus 10. So 2x minus 12x is minus 10x. Finally, the constant term on its own is minus 24, so just bang that on the end, and we have our final simplified answer. X cubed plus 3x squared minus 10x minus 24. Question 15, we're talking about fish. So a pet shop has got 7 guppies, 13 tetrafish, and 5 angelfish. So David is going to want to choose one of the following combinations. So there's 3 different types to choose from: guppy, tetra, and angel, of color coded in red, blue, and green, respectively. So you could either pick a guppy and an angelfish, 7 and then 5 angels, or a tetra, of which is 13 and an angel, 13 tetras and 5 angels, or you could pick one of each. So first combination, if there's 7 guppy fish and 5 angelfish, that means there's actually 7 times 5, which is 35 combinations if you went for this first scenario of a guppy and an angelfish. So 7 times 5 would be 35 combinations for this first option. If you went for the second option and picked one of the 13 tetras and one of the 5 angelfish, then that would be 13 multiplied by 5 for this scenario, which would be 65 combinations. Or finally, if you had one of each, that'd be 7 guppies multiplied by 13 tetras multiplied by 5 angelfish. Couldn't even say the number 5 then, which is 455 combinations. So in total, we need to show that this adds up to 555. So the only thing we need to do now is just prove to the examiner we've added these up and it comes to 555. Always worth just double checking, of course, to make sure we've not made any errors. So 35 plus 65 plus 455, does that work? Big relief, yes it does. So we just add these together, sum them, and then we can just conclude that yes, there is 555 total ways like the question wanted us to prove. So we've proved it, therefore we're done and can move on to the next one. Question 15, ABDE is a cyclic quadrilateral. So that's a massive clue that it's a circle theorem question, and we'll need to know about a theorem involving cyclic quadrilaterals. Also, ABC and EDC are straight lines, and we're told that angle DBC is 60 degrees. So I'm going to label this on first of all. So DBC is 60, which is that one. And the first thing I'd probably do is think, well, I know that angles on a straight line add up to 180. So if that one's 60, I can work out the angle at B, which is angle ABD. This one here is going to have to be 120 degrees. So I can say that straight away. That's probably the easiest thing to work out. So if I just say that angle ABD is 120, and give a reason, because the question does say to give reasons and show working. That's because angles on a straight line add up to 180 degrees. As obvious as it is, do state them. The next thing we're told is the size of angle EAB to the size of angle BCD. EAB is this one, BCD is that one down there, is in the ratio of 2 to 1. So all that means in plain English is whatever this angle is here, this one there is going to be double as big. I don't know what either are. If it's an unknown quantity, I tend to call it x. So I'm going to label this angle here x, and the angle at A, I'm going to label 2x. Now we need to think about what it said about these cyclic quadrilaterals. So what we need to remember is that opposite angles in a cyclic quadrilateral add up to 180 degrees. So thinking about this one here, the green, if that's 120, this one here at E must be 180 minus 120. That one's going to be 60 degrees. Similarly, the one opposite to 2x, which I've colour-coded in blue again, if that's 2x, this one down here will be 180 minus 2x. But rather than just labelling, explain it to the examiner that you've used the circle theorem that opposite angles of a cyclic quadrilateral add up to 180 degrees. So just saying that here explicitly to make sure you get full marks. Then you need to work out the angle of BCD, which is essentially x. So I know two of these angles in a triangle. I don't know this one, but I do know that the other side of this angle here is 180 minus 2x. If that's 180 minus 2x, this bit here, which I'm going to colour code in pink, that must be 2x. So that that one plus that one adds up to 180 degrees because EDC is a straight line. So state that again. ADC is going to be 2x degrees because angles on a straight line add up to 180 degrees. Finally, after all that hard work, it's now quite simple. We can just focus in on just this triangle here. So if I just get rid of everything else, because nothing else is needed now, I'm just going to zoom in on this triangle that's left. So say goodbye to everything else. This is just an unhelpful distraction now. So this triangle here. Angles in a triangle add up to, obviously, 180 degrees. So 60 at the top, plus 2x in pink, plus the x in purple, has to add up to 180 degrees. Simplify. 60 plus 3x is 180 degrees. Take 60 from both sides to get 3x on its own. Then get that 3x equals 180 degrees minus 60. In other words, 3x is 120. Finally, divide both sides by 3. 120 divided by 3, x equals 40 degrees. So in other words, BCD, which is x, is given by 40 degrees. Question 17 is a pretty brutal ratio question. I'm going to explain this in one of two different ways. So there's 4 boxes on the shelf, A, B, C and D. The total weight of A and B is 3 times the total weight of C and D. What an absolute mess. I'm not even going to explain it, I'm just going to run straight in and just pick it through with you. So let's just think of this. So A to B is 3 times the total weight of C and D. We're told though that the weight of A is 2/3 of the weight of B. So let's imagine the ratio of A to B. So A is 2/3 of one lot of B. If I multiply both these numbers by 3 though in the ratio, I can make that into a better looking ratio of 3 to 2. So I'm going to put that 2 and 3. And we're told though that the total weight of A and B is 3 times the total weight of C and D. So C and D combined, if I look here, C and D combined, if that's 2 parts for A and 3 parts for B, that's a total of 5 parts. But A and B is 3 times bigger than C and D, so if that's 5 parts, C and D combined will be 1/3 of that, which is 5/3. Now again, fractions within ratios makes it seem much harder. So how could I get rid of that 5/3? Well, what I could do is multiply all parts of this ratio by 3. I'd then get 2 times 3, 6, 3 times 3, which is 9, and C and D combined is 5. It next says, though, about C and D, that C and D is in the ratio as follows. So C is 75% of the weight of D. So I need to split these 5 bits here. So D is 1 lot, and 75% of D would be 0.75. So in other words, I need to split 5 into the ratio 0.75 to 1. So what I can do here is think about this in terms of scaling. So 1 plus 1.75, sorry, 1 plus 0.75 gives 1.75. So what I need to do here is to divide 5 by 1.75, which I'll show you here. 5 divided by 1.75 gives 20 over 7. So in other words, this here is going to become 1 lot of 20 over 7, and this here will be 0.75 lots of 20 over 7. So if I multiply that by 0.75 now, I get 15 over 7. So at 5, for C is going to be 15 sevenths, and for D, 20 over 7. I've got a better way of explaining it in a second. I'm not saying I'm a fan of this way, even me. So I've got 6 to 9 to 15 over 7 to 20 over 7. However, like I say, try to avoid fractions mixed in with ratios. So I can get rid of these sevenths by multiplying all bits by 7. So 6 times 7, that gives 42. 9 times 7 is 63. That just becomes 15. And 20 over 7 times 7 simply becomes 20. Double check if this simplifies. It doesn't, because there's no common factors. So therefore, the ratio of A to B to C to D is 42 to 63 to 15 to 20. The second way I'm going to show you is my preferred way. It's more sort of a trial and error way, but it's much neater. And once you practice the method a bit more, it's actually simpler than this way. So that's purely using ratio. What I'm going to suggest, though, is to try a different approach if you didn't like that approach. Essentially, what we could do is try some nice numbers. I put nice in inverted commas because that's a bit of a silly phrase to use. By nice, what I mean is whole numbers which are easy to work with. So what I'm going to say here, A and B, they're 3 times larger than C and D. So I'm going to start off with C and D because it's easier to scale up by multiplying than it is to divide. So I'm going to start thinking about C and D. So I've got here, the weight of C is 75% of the weight of D. So just imagine, let's say if D was 100, just make up a nice number, 100's a nice number, then 75% of 100 is obviously going to be 75. A and B is 3 times bigger than the total weight of C and D. So C and D combined is 75 plus 100, which is 175. Multiply that by 3. The total of A and B, if D was 100, would be 525. So A and B combined would be 525. But it says here that the rate of A is 2/3 of the weight of B. So 2/3 plus 1, 2/3 of B plus 1 lot of B, that's 5/3 of B in total. So if I split this to work out what B is and A, I need to work out, basically, I've got 5/3 in total. I need to divide this into. So what I need to do here is divide this, because I've got 5/3 2 of which are for A, and 3/3 equal to 1 unit for B, I need to do 525 divided by 5. So 525 divided by 5 is 105. 2 of those thirds are for B, so if I multiply that by 2, 2/3 is for A, so 210 for A, and then B would be 3/3, so divide by 2 to get my 1/3 back, multiply by 3, 315. So then, that would mean that if this were the case where D is 100, I'd have 100, that's 75, and that 525 would be split 210 for A, 315 for B. Another way you could have done this, by the way, you could have said 2/3 of an x, where x is B, plus x equals that 525, and then solved like that. You would have got x is 315. So now we just need to simplify this if we possibly can. So we need to think of common factors of 210, 315, 75, and 100. So each of these values end in a 5, therefore we can divide them all by 5. So on a calculator, 210 divided by 5 would give 42. That divided by 5 gives 63. 75 divided by 5 is 15. And 100 divided by 5 is 20, giving the same solution as what we had before. That's my preferred method. It's not always easy to spot. You just need practice, practice, practice to get good at knowing what to do with these fairly horrible ratio questions like this. Question 18 took me by surprise when I saw it. It's talking about reflection and describing the single transformation, and you're not given a coordinate grid. I equally love and hate this question because it really tests for deep understanding, but it is quite nasty as well, I feel, but I can't help but respect the question. So what I'd say here, rather than trying to freak out and think, I've got no idea, I've not got a grid, where's the line, what am I doing, sketch it out and just suck it and see. So sketch out a grid. I'm sort of cheating because this is better than a sketch because I've got a computer. But just sketch out and just think about it by trying some points. So first of all, one line of reflection is x equals 2. So if I draw this on, like so, and then it's reflected in x equals 6 to give shape C. X equals 6 is a vertical line going through at x equals 6, like so. So I'm just going to try some points. So just try something. So shape A, the easiest shape I can think of is just a single dot. Where to put the dot? Put it wherever you want. I'm going to put A here. So if it starts there, it's then reflected in the red line. So that hop over to the other side here. And then this one is then reflected in the blue line. So it goes, it's 3 away from the blue line on this side. So another 1, 2, 3. It goes there. So this point here ends up all the way over there. 1, 2, 3, 4, 5, 6, 7, 8. It's just moved 8 to the right. If you're unsure, you want to try a different point, be my guest. So if I were to take, I don't know, let's say, let's go for this point here, where x is -1. If I reflect this in the red line, 1, 2, 3, 1, 2, 3, like so. Reflect it in the blue line, 1 away on this side becomes 1 away over here. So we go from here to here. Again, what's happened? So you can see in each case, and in fact any case you would consider, we're moving 8 units in the x direction. So all that would happen to this shape is it's going to be a translation 8 units to the right, and we do that using column vectors. So if we go 8 to the right, that means 8. We're not going up or down, we're just moving horizontally only, so it's 8, 0. That's the vector we're translating by. That therefore is our answer. So I'm going to underline it in red to say we're done. Question 19. There are only blue counters, red counters, and green counters in a box. The probability of a counter taken at random from the box will be blue is 0.4. So 0.4 means it's a 40% chance. So I'm going to just highlight that first of all, in fact. So if a chance of a blue is 0.4, that's one and the same thing as saying 40% chance of it being blue, therefore 40% of the counters are blue. And because there's only blue, red and green, if there's a 40% chance of a counter being blue, that means the other 60% of them must be either red or green. So that's the implication we need to deduce for ourselves. It then goes on to say that the number of red to a number of green is split in the ratio of 7 to 8. Now she takes at random counters from the box, records a colour, puts it back, and does it 50 times. Samina must be bored, is all I'm thinking. Anyway, we need to work out the estimate for the number of times she takes a green counter. So what we're interested in here is the green counters. So we know that 60% of the counters are red or green. We also know the ratio those counters are split into is 7 to 8. So we can actually deduce what percentage must be green. So red to green in ratio 7 to 8. At this point I'd normally do a ratio table, something like this. So red to green is 7 to 8. 7 lots plus 8 lots gives us a total of 15 lots to this ratio. But the total of 15 lots must equate to the total of 60%, because in total 60% of these counters are either red or green. So if 15 parts in total relates to a total of 60%, then what we can say here is to go from 15 and scale up to 60, we need to multiply the value of 15 by 4. And if we do that to this bit of a ratio, to keep it all in proportion, we therefore need to multiply all values by 4. So if we multiply all these numbers by 4, 7 times 4 tells us 28% of the counters are red, and 8 times 4 means 32% of the counters are green. So we can now answer the question. If she takes a counter 50 times and puts them back 50 times, then 32% of that time you'd expect them to be green. So our best estimate is if 32% of the counters are green, then 32% of those 50 times will probably be green counters she picks. So 32% of 50 is what we need to calculate, and 32 shift percent of 50. You can do it in a few different ways, of course. You could write 32 over 100 times 50. Ultimately, it should give you 16 times she gets a green counter. Question 20. You have a diagram showing a triangle A, D and D. So AE is the same size as DE. So that side here is the same as ED. So I'm going to just label these in green like so. And so this whole big triangle from A to D to E, if it has two sides which are the same, then it must be an isosceles triangle. Therefore, this is a line of symmetry down the middle of a triangle, and we need to remember that if a triangle is isosceles, not only do we have two green sides, which are the same, but the base angles will also be equal. So the angle at A, which is EAD, and the angle at D, ADE, will also be the same. So EAD is the same as ADE for the reason that base angles of an isosceles triangle are equal. So I'm going to add these in yellow like so, and this is going to form part of our proof. The next one we're told is a ratio of AB to BC to CD is 1 to 2 to 1. So if I add this in here, I don't know what the 1 is, the 2 is, or the 1 is. But what I do know, for example, is that from B to C is double the length of A to B. If we don't know something in maths, I tend to call it X. So I'm going to label AB X, BC 2X, and CD as just 1X. So, proving that ACE is congruent to DBE, what I'm going to do now, I'm going to imagine this triangle split into two. One triangle here, EAC, I'm going to put here, and the other bit from E to B to D, I'm going to put next to it, so we can compare and contrast. And so looking at ACE, we can see here that obviously the angles are the same, like we've said, and as well as that, from A to C is x plus 2x, which is 3x, and from B to D is 2x plus x, which is also 3x. Therefore, if AC is 3x and BD is 3x, AC is the same as BD. Next up, AE is the same as DE. We were told that in the question, and also we have established that the base angles are the same. So we've got here, that side is the same in both. That side, the other side of the angle is the same. And the angle trapped between the two same sides is also the same in both triangles. Therefore, they are congruent to each other. What you need to state as well is ACE is congruent to DBE, but you need to be saying SAS. That stands for side angle side, which means that a side is the same, then next to that side we have an identical angle, then the other side of the angle, immediately following it, is another side which is the same for both. That's a test of congruency. That side, that angle, and the following side is identical in both. That's sufficient to prove that one triangle is identical, in other words, congruent to the other one. Question 21. We have an equation of a curve which is y equals 4x squared minus 56x. The curve has one turning point. By completing the square, show that the coordinates of the turning point are 7 and minus 196. So what we need to do here, as it's instructed us, is to complete the square. Now, we can only really complete the square when the coefficient of x squared is 1. Here it's not. We've got that 4. So that 4 needs factorising out. So if I factorise out a 4 from both of these bits, I get 4 lots of x squared, and then 56 divided by 4, feel free to use a calculator, gives 14. Now we complete the square on the stuff to do with x. The constant 4 on the outside we're going to leave alone for now. So I'm going to leave that 4 standing. We're going to complete the square on the yellow highlighted part. Now the way we do this, instead of an x squared, we write in the x, and the number in front of the normal x without the squared, we simply half that coefficient. We half the number in front of it. So half of minus 14 is minus 7. We then square all of that, and then we always subtract away this value here squared. It's always a minus sign. In this case, because minus 7 multiplied by minus 7 is positive 49. So we take away that 49. Now at this stage, we can again expand back out. So we've got 4 lots of x minus 7 all squared, and then 4 multiplied by minus 49 gives us the minus 196 as required. So we can see here that we've got a minus 7, that relates to that 7 in the turning point, and minus 196 relates to the 196 in brackets. So therefore we can say from here we've got our answer essentially. So therefore, turning point is when x is positive 7 and y is minus 196. That's all we need to do, and we're done. (22) Algebraic fraction time. So we have to show that this particular beast here can be transformed into this particular beast over there, where a and b are integers, essentially whole numbers that are allowed to be negative, is what an integer means. We then need to find the value of a and b, and showing all working. So if we were adding fractions together and it was just numerical, we'd have to get a common denominator, and it's no different here. So the best way we can get a common denominator for these two fractions would be to multiply one denominator by the other. So we'd multiply x minus 5 by x plus 5, and vice versa, we'd times x plus 5 by the x minus 5. And so the first step is to get the whole thing over the same denominators. So the first one, if I multiply x minus 5 by the x plus 5, then obviously I need to multiply the top by the same as well. So then I do 2x plus 3 multiplied by the x plus 5 too. Then this one, same idea, but this time multiplying both top and bottom by the x minus 5. So this time I'm going to do x plus 5 multiplying by the x minus 5 to its left, and therefore also doing the same to the top of the fraction. So I'm doing x minus 4, x minus 5. Finally, the minus 3, we also need to do the same there. So we can think of 3 as being 3 over 1. So we're going to multiply the 3 on top and the 1 on the bottom by both x minus 5 and x plus 5. And so that's going to give 3 lots of x plus 5 or x minus 5 first, doesn't really matter which order, x plus 5 over 1 lot of x minus 5 and x plus 5. So that's what we're working with here. So now at least we have a common denominator for them all. So we've got some expanding brackets to do. The first thing to note is that on the bottom of all these fractions, x minus 5, x plus 5 is what we have for all. If we were to expand this out, you need to spot ideally. Without doing it, a quick spot is needed. This is a difference of 2 squares. If we do x plus 5 expanded by x minus 5, that's how we get the x squared minus 25. So what we can do next is we can replace the denominator with its x squared minus 25 form, which is the same as this when you expand it, and put it all over x squared minus 25. What we need to do now, though, of course, is to expand these brackets on the top. So with the help of a good method, which I've got here, I'm going to do it step by step with you. So the first one, I need to do 2x plus 3 multiplied by x plus 5. So multiplying this out, 2x multiplied by x is 2x squared. X multiplied by 3 gives 3x. 2x's times by 5 gives 10x. And finally, 5 times 3 is 15. So this one here becomes 2x squared, in total 13x plus 15. So that one goes to 2x squared plus 13x plus 15. This one here, we have x minus 4 multiplied by x plus 5. So let's see what this one goes to. So x minus 4 here, multiplied by x plus 5. Sorry, x minus 5. Need to read carefully. So step by step, x multiply x is x squared. X multiplied by minus 4 is minus 4x. X multiplied by minus 5 gives minus 5x. And minus 4 multiplied by minus 5 gives positive 20. So simplifying all of this, we have x squared minus 4x minus another 5x is minusing 9x's in total, and of course, plus 20. So then we have an additional x squared minus 9x plus 20. And then, I'll just make myself a bit more space, as I always tend to run out. This one here is 3 lots of the difference of 2 squares. And so 3 lots of essentially the denominator would be 3x squared minus 75. But be careful because we're minusing this away. So we're minusing away on the top 3x squared minus 75. So subtracting 3x squared, of course, is just minus 3x squared. And now be very careful, we're now subtracting minus 75. Minus makes plus, so we're going to add 75 on. All of that over x squared minus 25. So now it's a case of simplifying down. So let's have a look at the x squareds. I've got 2x squared here, plus x squared is 3x squared, which cancels perfectly with that minus 3x squared. So we have no x squareds left, which is a relief because the question says we need to leave it with just x's and a number. So it's a good job they cancel. We know we're on the right lines at least. Now we need to look at just the normal honest-to-God x's. So we've got here 13 x's minus 9x's over here. So 13x minus 9x will give us overall 4x's. And finally, just the numbers on their own. I've got positive 15 here, positive 20 there, which is positive 35, plus another 75, which makes a total of 110. So on the top, I'm going to have 4x plus 110. On the bottom, of course, x squared minus 25. So a, the number in front of the x, is therefore 4. So our final answer from this, we can conclude that a equals 4. and b for number on its own is 110. So just state that clearly, because the question does ask you to say what a and b are. A's 4, b's 110, and we're done. Question 3, we're talking about graphical transformations. So we're given here the shape of a graph y equals f of x, shown here as this black curve. And on the same grid, we need to sketch the graph of y equals f of x plus 2. So the input of a function, in brackets, the x, has been changed from an x to an x plus 2, like so. So we need to consider what happens with this change. Well, if the change happens according to the input here is x, and the input's changed from x to an x plus 2, and also as well the input is inside these function brackets. So when the change occurs to f of x inside the function brackets, it will affect the x coordinates only. More than that, as well, it works opposite to common sense. So the shorthand way I think about this is inside equals opposite. When the change to f of x happens inside the brackets, it affects x in an opposite to common sense way. So here the change is just x to x plus 2. So this plus 2 is the change. Common sense would probably tell you, well, we're just going to add 2 to the x coordinates. That's what it looks like. Whereas actually what happens is the x coordinates move backwards by 2 units. So this plus 2 is actually going to have the effect of moving negative 2 in the x direction. So this point here will move 2 back to here. That minimum will move 2 back to here, and so on. So what we need to sketch is something like this in red. So all points just move 2 to the left, but nothing moves up or down. The y coordinates are not affected. Part B, again, graph transformations, but this time A has been reflected to give graph B. So y is g of x, which I'll just write on here, and we need to write down an equation of graph B. So what's been affected? The x coordinates or the y coordinates? Well, for any one point here, we can hopefully see the x values haven't changed. For example, when x is, that's about 2/3, x is the same value down here. When x is, at this point here, when x is 2, minus 2 rather, it goes to the same point. And if you have a look at the corresponding y values, they have changed in a particular way. For g of x, at this point x was 3, it goes down to minus 3. At this point it was 2, it's gone down to about minus 2. So what do you multiply 2 by to get minus 2, or 3 by minus 3? Same question I could ask, what do you do to reflect a graph in the x-axis like it has been? You basically multiply the y-coordinates by minus 1. If we're changing the y-coordinates, the change happens outside of the function brackets in a common sense way. So graph B is going to be y equals g of x, all multiplied by minus 1. So the y values flip over. Now this is better written as just y equals minus g of x. And that's the transformation that gets us to graph B. Question 24, we have these dreaded vectors again. C, D, E, F is a quadrilateral. From F to E is given in terms of vector A, E to D is labelled as B, C to D is labelled as 2A. The point P is such that from C to E to P, there to here to somewhere down there, is a straight line, and CE is the same length as EP and the same direction. So if C to E is here, E to P will be somewhere around here. So I'm just going to add on here point P and the line CEP. So in green, CEP will look something like this. We now need to use a vector method to prove that CF is parallel to DP. If one vector is parallel to another, the main thing you need to remember is that one of those vectors can be written as a multiple of the other one it's parallel to. If we can show that, we've proven it. So let's first of all think about this vector CF. So using the vectors we know, how can we go from C to F? Well, to go from C to F, I don't know the direct route, but I could go from C to D first. Once I'm at D, I could go from D to E. And then once I'm at E, I can go from E back to F. So in terms of the vectors as they're labelled, C to D is 2A. From D to E is going to be opposite way to B. So rather than positive B, it'll be negative B, because it's going to be opposite way round. And from E to F is along this A vector, but the opposite direction. So rather than positive A, that's going to be minus A. Simplifying, 2A minus A is obviously just 1A and minus B. So we know that vector CF is therefore A minus B. What we need to think about next is the vector from D to P. So from D to P is down here. So from D to P, what we could do to go from D to P, we could go from D down to E first. And then once we're at E, we can go to P. But from E to P, we were told is the same as C to E. So I can change this to DE, and I can switch EP with C to E. To go from D to E, I go along this vector labelled B, but the opposite direction, so D to E is going to be minus B. And then the vector CE, from C to E, I could go along C to D, and then down from D to E. So CE is CD plus DE. Now DE, again, is minus B, so this here is just going to be another minus B. And from C to D, from one to the other, is going along this direction in the same direction as the arrow, so that's going to be positive 2A. So simplifying this fully, I have 2A, and minus B minus another B is of course minus 2B. So therefore we can see that DP is 2A minus 2B. And the vector from D to P is this direction here. So comparing the two, these two here, we can see, therefore, if I multiply A minus B by 2, I get 2A minus 2B. So in other words, CF is a multiple of, sorry, DP, my mistake, terrible. D to P is a multiple of CF. D to P is double CF. Therefore, we've shown that one is a multiple of the other. DP is twice CF. And so we just conclude DP is parallel to CF as required. So that's all we need to do for that one. Question 25. This one is actually a bit simpler than what it looks, but I'll talk you through. We have a pyramid P, which is formed by two parts made from different material. So pyramid P is the whole thing, which comprises of top bit and this bottom bit here. So it talks about a top part, talks about a bottom part, and it mentions the average density of P, which is the whole thing combined. So we're talking about three different things here. One thing is the top, one thing is the bottom, the third consideration is the whole pyramid, the top plus the bottom combined. You can also spot here, we're talking about density, so you can bet anything that you're going to be needing this formula here. So density is mass divided by volume, which we can use a formula triangle for. And because we've got density, mass and volume, three different things, and as well top, bottom and the whole thing, another three things, to just section out all this information, which otherwise could be quite overwhelming, I'm going to strongly suggest we put this information carefully into a table, something like this. Now we can just infill what we need. So let's just fill this in step by step. So the top part of P has a mass of 92.8. So the top has a mass 92.8. It's made from a material with density of 2.9. So the density of the top is 2.9. What I can do now, I can work out the volume of the top. To work out the volume, I cover up what I want to find. So cover up V. The V is the mass of it divided by the density of it. So 92.8 divided by 2.9 will tell me the volume of the top. So let's calculate this first. So 92.8 divided by 2.9 tells us that the volume of the top is going to be 32. Now let's see what else we can fill in. So down here it says that the bottom part of P has a mass of 972.8. So the bottom's mass, 972.8. I can now work out the total mass. 92.8 plus 972.8 will tell me the total mass. So let's calculate that. So 92.8 plus 972.8, that gives us 1065.6. That's the total combined mass of the whole pyramid. It also says the average density of P, where P is the whole pyramid, is 4.7 grams per cubic centimetre. So the density of P, I'm going to fill in here, is 4.7. I can now calculate the volume of the whole thing. So the volume again is the mass of it divided by the density. So for the whole thing combined, the total, if I calculate 1065.6 divided by 4.7, I've got the overall total volume. So let's do that. 1065.6 divided by 4.7, that gives us a total of 226.7234, and so on and so on. So 226, what was it again? 7234, and so on. Now just bear in mind what we need to calculate. We want to calculate the volume of the top part of P as a percentage of the total volume of P. So we've got the total volume of P, so we've got one ingredient we need, and the other bit we need is the volume of the top part. So the volume of the top part of P is essentially this bit here. So we've got everything we need. We don't need to fill in the other bits. First of all now, what I'd think about is what's the volume of P as a fraction of a total volume? Well, as a fraction, we're going to have 32 out of 226.7234. That's how we'd write it as a fraction. However, we need to work it out as a percentage. So as a percentage, we can change from a fraction to a percentage by multiplying the whole thing by 100. So the final step we need to do, that 32 is a fraction of that 226. This answer's stored on my calculator, so I'm going to leave it like that. So if I press 32 divided by that stored answer, which was the total volume, multiplied by 100, press equals, we get 14.114. So to one decimal place, it's going to be 14.1%. And that's what we need to do. That's our final answer. We can now think about the last question on the entire paper. So we're nearly done. Well done for getting this far. And so we come to question 26. Never known a paper with so many questions on them, but this is obviously quite hard being the last question, but let's have a look at it step by step by step. This is actually, in my opinion, quite a nice last question because it gives you a very generous clue in the first line. So A, B, C, D, E, F, G is a regular heptagon. So it's got 7 sides, but this keyword regular means that if you've done some revision on regular polygons, you should be able to pick up at least 1 or 2 marks straight away. So picking up on this word regular and just recapping with you what it means. What it means in plain English is the sides are the same and all angles inside and outside the shape are the same. So I'm going to label all of these sides on the outside X. I can call all of them X because they're all the same length, knowing that it's regular. And as well as that, I can extend these lines going outwards to consider the size of the angles on the outside, and they do have a more technical name. So if I highlight these in yellow, these are actually called the exterior angles. So if I call these all big E, E for exterior, we need to remember how to calculate the size of each exterior angle of a regular shape. So for example, if I were to start here, imagine it's running around a lap of this 7-sided field. If I were to do one lap starting at A and go all the way around, I would have ran around a full 360 degrees. I would have circled around the shape. So I would have had to have turned around 360 degrees though by going around 7 equally sized corners. Therefore, the size of each outside corner, the size of each exterior angle, we can calculate by doing 360 divided by 7, which is 51.428. your calculator will give you a recurring decimal. Don't round it yet. Allow your calculator to have that stored in its memory. So if I just show you that one, 360 divided by 7 gives that. So just leave that there for now. Next, we need to consider the angles on the inside of the shape. So I'm just going to highlight that in yellow, as these are highlighted in yellow. Now considering the inside in green, I'm going to highlight these green ones, I, for interior. Now the exterior and interior always lie on the same line. So we need to remember something about the exterior and interior angles. I'll give you a couple of seconds to see if you can already. You should have thought about this. Essentially, this is just saying the interior plus the exterior, being that they're always on a straight line, will always sum to 180. Therefore, because we worked out the exterior, we can just do 180 subtract this 51.4, whatever it is, to calculate the size of each green interior angle. So the next step, say goodbye to smiley face, we have that each interior angle will be 180 minus that 51.428, which will give us 128.571 degrees. So next, we can pick at triangle ABG. So ABG is just this triangle at the top, which I'm going to colour in blue. And now, because we know that each side here is x and this is x, so therefore it's an isosceles triangle, and we've worked out that the interior is 128.571, we actually have enough information about this triangle in question now to actually calculate the length of GB. So GB is here, so it's all about this top triangle. So essentially we can now forget the fact it was a regular heptagon. And the second stage, I'm just going to focus in on this blue triangle with a green angle. So if I just make a bigger version of it here, we can then think about what GB will be. But before we do that, we could do with working out this unknown side, x. This is x and the other one's x. So the next thing you need to notice, we're told about the area of this triangle. We're told that the area of the triangle is 30 cm squared, and we need to remember this formula for the area of any non-right-angled triangle, or indeed a right-angled one. So the area of any triangle is half times AB times sine C. Again, in plain English, it means half multiplied by the both sides which surround an angle, in this case x and another x here surround with an own angle, then multiplied by sine of the angle you know, in this case 128.57. We know the area is 30, we know angle C is 128.57. So if we plug this into this formula here, 30 goes on the left hand side, then half AB is going to be half times x times sine of 128.571. So here's our starting point to work out what x is. Let's just simplify this slightly. Half multiplied by x is just obviously half x squared. So 30 equals half x squared sine of 128.571. Let's just neaten this up slightly. Well, the suggestion would be now to double both sides to get rid of this fraction. So if you multiply both by 2, that'll give us that 60 equals x squared multiplied by sine of 128.571. Rearranging, we can isolate the x squared by dividing both the left and the right of this equation by sine of 128.571. So if we do that, we get what x squared is, an expression for it anyway, so x squared will be 60 divided by sine of 128.571. The final step, we take this here on the calculator and square root the whole thing, because the final step is to square root, so sine 128.571, and so on and so on. So on here, just square rooting both sides like I say, we should get a value for x as 8.760. So here, if I square root both sides, you can see I do get 8.760. So I can fill in that x is 8.760, and then move on and now consider how we can use that information to finally calculate what we need for the length of from G to B. So I'm going to add this on here and make some more space for myself on this right-hand side. So now there's actually two different ways of calculating GB. I'll run you through both main methods. So one method we can use is actually the cosine rule for GB. Depending on when you've done this exam, whether it's been just very shortly after COVID or later on, there's maybe a mock, you may or may not, I can't predict the future, be given what the cosine rule is. Assuming you aren't, it can't help to know it anyway. The cosine rule is as follows. It's a squared equals b squared plus c squared minus 2bc cos a. So a, the subject here, well, a squared is a subject. I'm going to label as the side I want to find. So I want to find GB. I'm going to call this a. So essentially all I need to do is to get a, square root this whole thing. So if I just square root, that's what I'm after. So this side a is a square root of one side plus the other side, I know, both of them 8.760, of course, minus 2bc cos a, where a is the angle opposite to the side I want to know. That's going to be 128.57. So if I just infill, pour it all into this formula, so b squared is 8.760 all squared, as is c squared, because that side's the same as the other. Then minus 2 times 8.760. Again, not left myself enough space. I never seem to learn. Should be embarrassing, I suppose, but whatever. Times another 8.760 multiplied by cos of 128.57. So if I just carefully type this into the calculator and then round it to the appropriate accuracy, we should finally end up with what we need. So doing this together, step by step. So we're going to have, give myself more space, square root. In fact, I've got my answer stored, I think. Yeah, I'm going to use that. So square root of that squared plus another one of itself squared minus 2 times 8.760. Forgot the decimal there. Apologies. So minus 2 multiplied by that again, multiplied by cos of 128.571 we had. Press equals 15.785 and so on. Then we need to round that to 3 significant figures, 1, 2, 3, which is the same as rounding it to 1 decimal place. Next to the 7 is an 8. That 8 pushes the 7 up to an 8 as well. So we're going to have 15.8 centimetres as our final answer for what GB is. Another way we could have done this would have been to have used more simple trig for GB. So if I just clear this off now, I'll talk you through a different method, not relying on the cosine rule. So what I'm going to do here is consider this triangle split into two. It's isosceles, so it has a line of symmetry. So if I were to just draw in this line of symmetry here, and then consider that G to B can be split into two different parts. One half here, from G to directly below A, and the other half from directly below A all the way to B. So essentially what I'm going to do now is just focus in on just half of this larger triangle to make a smaller right-angled one with a right angle here. So if I'm going to just half the triangle, by symmetry I'm going to half this angle as well. And so all I'm actually doing here essentially is just going to cut off like that and leave me with considering this here. So from G to B, that angle, 128 point whatever, gets halved to this. And I can actually then calculate from G to the midpoint, then double it to find all the way across. So let's just consider this using simple SOHCAHTOA. So I want to work out of this one. So relative to the angle I know, that's the opposite side. That's the one I want to know. The side I do know, 8.760, is the hypotenuse. So the SOHCAHTOA triangle, which includes H and O, the side I know and the side I want to know, of course, is going to be SO for using sine. So to work out the opposite side, I want to work out the opposite, so I cover this up. The opposite side is S multiplied by H. So the opposite side is S times H. S stands for sine of the angle in question, so sine of 64.29, half of that 128, whatever it was, multiplied by 8.760, and then we'll get a value for the opposite. So just filling this into the calculator, So sine of 64.29, close brackets, multiplied by 8.760 gives a value of 7.89277 and so on. 7.89277. So therefore we know this one here is 7.89277. We can also, therefore, if I just be very lazy and just copy this, that's a height of laziness. How dare you, Mr. Bailey. We also know by symmetry that this one on the other side will also be 7.89277. So therefore, the full length of G to B from one end all the way to the other, in other words, all of that will simply be the answer on my calculator, this 7.89, whatever it is, multiplied by 2. So therefore, GB, 7.89, blah, blah, multiplied by 2. To get the calculator, simply double that, and then round to the same accuracy again. So to three significant figures, 15.7 goes to 15.8, because that 7's next to the 8 on the other side. So 15.8 cm. At least to three significant figures. And that's a wrap, said the man making tortillas. So I hope you found some of those questions useful. Please do leave some feedback if you'd like. Thank you very much for listening, and do take care of yourselves. And of course, goes without saying, but I'm going to say it anyway, the very best of luck in your upcoming exams, not just maths, but for all of them. So thank you again for listening, and I'll see you all soon.